Okay, example 5. What we're dealing with in example 5 are roots. And I have a square root, a fourth root, a third root, and another square root. And a root is like a power. As far as the order of operation is concerned, it would happen the same time powers happen. So if you see the square root of 16, that's going to happen whenever you do 2 squared and 3 cubed. So as far as order of operation is concerned, that's how you do it. And when you see a radical with no number in here, it's understood to be a square root. It's understood 2 there. What that number represents is how many factors you need to make the number that's in there. So what you're being asked is, what number times itself is equal to 64?
8.
And that would be 8, right? So the square root of 64 is 8. That's how you do a square root. All right? Fourth root, same idea.
It's what times what equals 6.
Exactly. Now we need to factor 4 times to equal 16.
It's 2.
And that'd be 2, right? So 2 times 2 times 2 times 2 is 16. So the answer to that is 2. When you evaluate a radical and it comes out to a nice pretty answer like 2 or 8, the answer is 2 or 8. There's no more square root symbol. There's no more symbol like that. It's just this equals 8, this equals 2. All right? When you're looking at even roots, this is a 2, that's a 4, there could be a 6th or an 8th or a 10th or a 12th or a 14th root. The number inside the radical is called the radicand. You can't make this stuff up, that's what it's called, radicand. All right? And the symbol here is called a radical. And the little number right there is called the index, in case you're interested. In case you ever get on Trivial Pursuit, or I should say one of these trivia things, Who Wants to Be a Millionaire? Are You Smarter Than a 5th Grader? What's the number underneath the radical symbol called? It's radicand. And then you win your $1 million, you can call me and say, Mr. Klein, I want $1 million. And I'll say, are you giving me some? You say, no. And I'll say, okay. That's what'll happen, right? Anyway, so, but radical, radicand, index. That's just what they're called. If the index is even, the number underneath the radicand has to be a positive number. Anybody think of a reason why? Want to try it out?
Because it's positive.
Let's try it. Let's try the square root of negative 4. Okay, we're looking for a number being multiplied by itself to make negative 4.
Well, why not?
And they got to be the same. Whatever this is has to be the same as that. They can't do it, right?
No.
Because I can do 2 times 2 makes positive 4. Negative 2 times negative 2 makes positive 4. To make a negative, they have to be different signs, but they're supposed to be the same. So there's no way to do it using real numbers. Okay?
You could do it if it was outside of it, though.
Yeah, outside we're fine. Like in this last example, we're fine. As long as it's underneath positive, we're in good shape. When you get to Algebra 2, lesson 51, I believe, we invent some numbers called imaginary numbers. We come up with answers to problems like that. That's Algebra 2. It's not today. Anyway, but just know that the problems you get should be fine. Notice this one's a negative underneath the radical, but its index is odd. Okay, that's possible because negative times negative times negative makes a negative, right? So in a situation like that, that's possible. We're looking for something times something times something equals negative 27. And obviously negative, 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 right? To make the negative, and 3, 3, 3. So the answer to that is negative 3. This last one, the square root of 81 is equal to 9, right?
Yep.
The minus sign out in front just means we want the negative square root.
I have a question.
What's that?
For like 8 or the first 2, do you want us to put both answers? Like 2 or because negative 2 could be an answer too?
If the problem specifically has the radical symbol on there already, square root of 64, they want the positive square root. If it's negative, they want the negative square root. If it has plus minus, if you see this symbol, plus or minus the square root of 9, let's say, that equals plus or minus 3.
Okay.
So whatever symbol they put in front, that's the one they want. So if they have no symbol, they want the positive square root. If they put a minus, they want the negative square root. If they put plus or minus, they want both square roots.
Okay.
There'll be times later on in the class where we're evaluating and where we're solving some equations, and we're going to be required to put the plus or minus on. But in these problems where they give the problem to you, it'll be what it is in the problem.